Hello everyone, good morning. My name is Wilhelmus Jr.
I'm Sheena Galvez, and
and
you
you
are
are
watching
watching
Isort
Isort
Mo
Mo
Na
Na
Yan.
Yarn. Before we're going to start this presentation, let me ask you something first. Have you ever heard of insertion sorting algorithm? How about sorting algorithm? Sort algorithm. Wala ba? Wala talaga. Worry not, because in this video, we will be guiding you in this sort journey. Kidding aside, this video will show and talk about first, the definition of insertion sorting algorithm, second, how this algorithm works, third, steps to implement this approach, fourth, the underlying analysis and simulation, fifth, the algorithm's time complexity, and last but not least, 6. A simple program that runs the idea of this approach. Before jumping on the topic, we will have a quick recap first. We have sort, algorithm, and sorting algorithm.
Sort. When we say sort, this refers to a term used to describe the process of organizing data in a particular order, allowing for information to be found easier. For example, names and contact information may be sorted in alphabetical order to allow the person looking for a name to see if it's available. Algorithm. When we say algorithm, this refers to a set of instructions for solving a problem or accomplishing a task. Every computerized device uses algorithms to perform its functions in the form of hardware or software-based routines. Sorting algorithm. When we say sorting algorithm, this refers to an algorithm made up of a series of instructions that take an array as input. It performs specified operations on the array, sometimes called a list, and outputs a sorted array. A sorting algorithm will put items in a list into an order, such as alphabetical or numerical order. Sorting a list of items can take a long time, especially if it is a large list. By the way, why do we study sorting algorithms nga ba?
One of the reasons why we study sorting algorithms is to explore and learn how to analyze the worst case time complexity, average case time complexity, and best case time complexity. Later on, we will expound that more. I would assume that you are now ready. Ready na ba talaga? Insertion sorting algorithm is a simple sorting algorithm that works the way we play the playing cards on our hands. For example, when you are playing your cards, normally you would sort it in ascending order through insert or insertion. This algorithm builds the final sorted array one item at a time. This means that, basically, we cannot compare this pair of numbers on my both hands at the same time. Instead, I should compare this first, then this one will follow. Lastly, insertion sorting algorithm is a sorting algorithm that places an unsorted element at its suitable place in each iteration.
The question is, how insertion sorting algorithm works?
Here is an example of an unsorted array. The size of this array is 5 and the arrangement is 1, 2, 4, 5, and 3. In an insertion sort's point of view, the array is virtually divided into sorted subarray and unsorted subarray. By default, in an insertion sort, we are already assuming that the first element is already sorted while the rest are the unsorted ones. For now, we are just going to observe and try to understand the behavior of this sorting algorithm. We now already have the sorted version of the unsorted array in the previous slide. The size of this array is still 5, but the arrangement of these elements change into 1, 2, 3, 4, and 5. Were you able to understand the concept? For you to fully understand this concept, I would like you to focus on our next slide. Steps for insertion sorting algorithm. First, pick the next element. Second, examine each item and compare it to the items of the sorted array. Third, shift all the items in the sorted array that is greater than the value to be sorted. Fourth, insert the value. Lastly, fifth, repeat until the list is sorted. Note that the loop moves from left to right and the comparison moves from right to left.
Now, you already have a basic understanding of insertion sorting algorithm. Let's jump into its analysis and simulation.
Here in this subtopic, we will be running a simulation of insertion sorting algorithm. Hence, we will also get its time complexity and a little bit of analysis. As you can see, we have here the unsorted array 1, 2, 4, 5, and 3. Then the pseudocode, which have 2 loops and 4 variables. The outer loop, step, or the iteration will start at 1 because the first element in an array is already considered as sorted. That's why, as per instruction, we have to pick the next element. Let me explain first the variable names and the function of the code. Array size is the size of the array. Step is the iteration of the loop. Car_lm means the current element that the loop is holding. lm_bef_car means the element before the current element. As for example, if the current element is 4, then the element before that current element is 2. There are 2 conditions in the inner loop. First, element before current must be greater than or equal to 0. Second, the current element must be less than the element before current. These 2 conditions must be true for the inner loop will run. Lastly, here in the array, index of element before current plus 1 is assigning the current element. Now, let's start the simulation. The value of the variable array size is 5, since we have 5 elements in the array. The value of the variable step is 1. The value of the variable current element is the array at the index of step, which is 2. The value of the variable element before current is 0 because 1 minus 1 is 0. On the first condition, the result is true because 0 is greater than or equal to 0. On the second condition, the result is false because 2 is not less than 1. Therefore, we ignore the inner loop. Now, in the current iteration, nothing has been changed because the array of index 0 plus 1 is still equal to the current element. Now, let's go back to the outer loop but in step 2. Value of the variable step 2 is 2. The value of the variable current element is the array at the index of step, which is 4. The value of element before current is 1 because 2 minus 1 is 1. On the first condition, the result is true because 1 is greater than or equal to 0. On the second condition, the result is false because 4 is not less than 2. Therefore, we ignore the inner loop. Now, in the current iteration, nothing has been changed because the array of index 1 plus 1 is still equal to the current element. So let's go back to the outer loop but in step 3. The value of the variable step is 3. The value of the variable current element is the array at the index of step, which is 5. The value of the variable element before current is 2 because 3 minus 1 is 2. On the first condition, the result is true because 2 is greater than or equal to 0. On the second condition, the result is false because 5 is not less than 4. Therefore, we ignore the inner loop. Now, in the current iteration, nothing has been changed because the array of index 2 plus 1 is still equal to the current element. Let's go back to the outer loop but in step 4. We just reached the last element of the array. The value of the variable step is 4. The value of the variable current element is the array at the index of step, which is 3. The value of the variable element before current is 3 because 4 minus 1 is 3. On the first condition, the result is true because 3 is greater than or equal to 0. On the second condition, the result is true because 3 is less than 5. Finally, both of the conditions are now true. What's happening is that the array of index 3 plus 1 is assigned to the value of the array at the index of 3. The value of the array at the index of 3 is 5. Then, it was moved to the index of 4. Then, we decrement the element before current variable. Now, the inner loop will run again if both of the conditions were true. First condition is still true because 2 is greater than or equal to 0. Second condition is still true because 3 is less than 4. So, the array of index 2 plus 1 is assigned to the value of the array at the index of 2. The value of the array at the index of 2 is 4. Then it was moved to the index of 3. We decrement the element before current variable. Now, the inner loop will run again if both of the conditions were true. First condition is still true because 1 is greater than or equal to 0. Second condition is now false because 3 is not less than 2. Therefore, we ignore the inner loop. Now, in the last code, the array of index 1 plus 1 is assigning the current 3. So as you can see, the unsorted array is now sorted. Asymptotic analysis. For n elements array, in first pass, we have one comparison. In second pass, we have two comparisons. Similarly, in kth pass, we have k-1 comparisons. And the last pass requires n-1 comparisons. Therefore, the asymptotic analysis is big O of n squared. Or, we could also call it as quadratic time. A short fun fact. Did you know that insertion sorting algorithm is one of the challenges that is used to test the capabilities of a programmer?
Fun fact yarn! Now, we already know how this insertion sorting algorithm works. The question is, when are we going to use this?
That's actually a very good question. To answer that, here comes worst case, average case, and best case.
The worst case time complexity of insertion sort is big O of n squared. When the elements are not yet in sorted order, when the array is sorted in a reverse order, when there is too many comparisons in the inner loop, and when n is the largest possible number. The average case is it occurs when the elements of an array are in jumbled order, neither ascending or descending. The best case time complexity of insertion sort is big O of n. When the elements are already in sorted order, when there is precisely one comparison in the inner loop, when there's no swap operation in the inner loop, and when n is the smallest possible number.
Kunting kembot na lang talaga. I know you are already excited na to see the program. But first, we need to share to you about our findings. In conclusion, we only use insertion sorting algorithm if the array has a small number of elements and there are only few elements left to be sorted. Because insertion sorting algorithm is not very efficient when the data sets are large. For us to prove our presentation, we created a program that sorts an array in an insertion sorting algorithm manner.
Hello scammer, we have been watching you. We know that you have been stealing money from people. If you do not stop, there will be severe consequences. This is your first warning. There will not be a second. We are anonymous. We are legion. We do not forgive. We do not forget. Expect us.
Insertion sorting algorithm in a nutshell. Insertion sort moves the item to the left until it finds the correct place. Then, it repeats until the end of the list.
I've tried searching in Google, insertion caught my eyes. It's a simple sorting algorithm, one of the sortings. My first time looking at it, I really don't understand. Can't get out of my mind. All day and all night, something is pushing me. That learning insertion is fun, and it makes your mental healthy. And it makes my heart race. Can't get out, get out of my head, and have a feeling of excitement. I know how to do this. Insertion is easy. Can't get out, get out of my mind, and come on, come into my life. Insertion, sorting, insertion, arrange from least to highest. Whoa, whoa, oh, whoa, oh, whoa. Arrange from least to highest. Can't get out, get out of my head, and have a feeling of excitement. Can't get out, get out of my head, and have a feeling of excitement. I know how to do this. Insertion is easy. Can't get out, get out of my mind, and come on, come into my life. Insertion. Sorting, insertion, arrange from least to highest.
And you are watching. I-sort mo na yan.
Fun fact yarn,